Every person on Earth is living in the past. This may sound like the plot to some sci-fi time travel thriller, but it's actually a fact of human biology and the trickiness of time. Our brains don't perceive events until about 80 milliseconds after they've happened. This fine line between the present and the past is part of the reason why some physicists argue that there's no such thing as now, and that the present moment is no more than an illusion. Hi, I'm Erin McCarthy, Editor-in-Chief of Mental Floss, and welcome to the List Show from my living room. The potential impossibility of living in the present is just one head-scrambling fact about time that I'm going to share with you today. Throughout history, different cultures around the world have experienced time in different ways. In the Western world, we tend to think of time as linear, flowing from left to right. But this isn't the case for everyone. Language affects how people conceptualize time, particularly the spatial metaphors they use to describe and map it. Those who read languages that flow from right to left, such as Arabic and Hebrew, generally view time as flowing in the same direction. The Aymara, who live in the Andes Mountains in South America, consider the future to be behind them, while the past is ahead. In their view, because the future is unknown, it's behind you where you can't see it. Some indigenous Australian cultures, which rely heavily on direction terms like north, south, east, and west in their languages, visualize the passage of time as moving from east to west. If they're facing north, for example, the past would be to their right, or east, whereas the future would be to their left, which would be west. Individual people can experience time differently too. You've probably noticed how time seems to speed up when you're racing against a deadline or having fun, and how it tends to drag when you're bored. This is because when you're focused on something like a big work project or a party, your brain pays less attention to how time passes. But when you're bored or your brain is less stimulated, you become more aware of the passing of time, making it feel slower. One study proposed that dopamine, the neurotransmitter and hormone that helps us feel happy, may be an additional culprit. It showed that increased dopamine production, which happens when you're enjoying something, may slow down your body's internal clock, making time feel like it's flying by. Science has a number of different ways of defining time. To discuss just a couple. There's astronomical time, which is measured in relation to how long it takes Earth to rotate on its axis. In astronomical time, a second is 1/60th of a minute. And then there's atomic time, which dictates the numbers you'll see on a clock. According to atomic time, 1 second equals 9,192,631,770 oscillations of a cesium-133 atom. Measuring the vibration of an atom, which in simple terms is the gist of what oscillation is the most accurate way to track time. We can thank Albert Einstein for a lot of our current understanding of the physics of time. Rather than viewing time as a set order, he proved that it's actually relative. For example, according to Einstein's theory of special relativity, there's an inverse relationship between your speed and the speed of time. The faster you move, the slower time moves. This is why someone blasting through space will age slower than the people still hanging out on Earth. Astronaut Scott Kelly was born several minutes after his twin brother Mark, but after Scott spent 340 days living on the International Space Station, he returned to Earth around an extra 5 milliseconds younger than his big brother. Had Scott been traveling at a speed close to the speed of light, that age difference would have become much more pronounced. Einstein's theory also states that gravity can warp time. If you've seen the 2014 movie Interstellar, this concept may seem familiar. The closer you are to a massive body, which in the case of Interstellar is a giant black hole, the slower time would pass for you. Gravity's effect on time isn't limited to intergalactic travel. Here on Earth, gravity can vary for a number of reasons, including your altitude, since you're changing your distance from the center of the Earth. That means if you put a bunch of synchronized atomic clocks at various altitudes, eventually these clocks would fall out of sync. A clock at the top of Mount Everest and one at sea level would, over the entire 4.5 billion year history of the planet, have diverged by about a day and a half. Gravity is also the reason why our days are getting longer. Over 1 billion years ago, a day on Earth lasted around 18 hours. Our days are longer now because the moon's gravity is causing Earth's spin to slow down. In Earth's earlier days, the moon wasn't as far away, which caused Earth to spin much faster than it currently does. Longer days also mean shorter years. Kind of. The time it takes the Earth to orbit the sun hasn't changed, but the amount of days within a year has. Back when the dinosaurs ruled 70 million years ago, days were only around 23.5 hours long, and the year was made up of 372 of those slightly shorter days. There are two ways to think of the length of a day on Earth. Though you probably learned that one day on Earth is 24 hours, it actually takes the planet 23 hours, 56 minutes, and 4.0916 seconds to rotate on its axis. This is the difference between a solar day and a sidereal day. A solar day is 24 hours, whereas a sidereal day is roughly 4 minutes shorter. We measure solar time based on the sun's position in the sky, whereas a sidereal day is measured based on the location of the fixed stars. In other words, a sidereal day is the time it takes for a distant star or constellation to appear on the same meridian. Because astronomical time and atomic time don't always line up, every so often we get a leap second. Earth's spin speed can be a bit unpredictable. Atmospheric winds, northern hemisphere winters with heavy snow, and other big weather systems can affect how fast the planet rotates. In order to keep the difference between astronomical time and atomic time to less than 0.9 seconds, the International Earth Rotation Reference System Service will occasionally announce the need for a leap second. Most people won't notice a leap second, but they can be a huge pain for tech companies. Because leap seconds are added irregularly, developers have no way of working them into their codes, which has caused websites like LinkedIn and Reddit to crash in the past. A bug caused by 2012's leap second caused so much chaos on Qantas's servers, more than 400 flights wound up being delayed, by more than a second, presumably. The length of a year on Earth can also get a bit complicated. The original Roman calendar was a bit of a mess, so much so that in 46 BCE, Julius Caesar mandated a 445-day-long year to help bring the calendar back in sync with the seasons. At the same time, Caesar asked the astronomer Sosigenes to help reform the calendar. Most years were set at 365 days, but to make up for the fact that the Earth's revolution around the sun doesn't take exactly 365 days, leap years were implemented. Every 4 years, the month of February was given an extra day to make up for what is sort of a rounding error in the calendar. But Sosigenes made a bit of a miscalculation, so the calendar continued to be a little off. He thought a year lasted 365.25 days, but it's actually around 365 days, 5 hours, 48 minutes, and 45 seconds, equivalent to about 365.242 days. This tiny error had some pretty big consequences. By 1577, the Julian calendar was off by 10 days. Meaning key Christian holidays were being celebrated on incorrect dates. Pope Gregory XIII took issue with this and established a commission to get the calendar back on track. In 1582, the Gregorian calendar was created. Rather than having an extra day every 4 years without exception, years that are divisible by 100, like 1700 or 1900, skip leap year, unless the year is also divisible by 400, like the year 2000, in which case the leap year is back on. Even this system isn't perfect, though. It has an error of 1 day in 3,236 years. We can thank the railroad industry for standardizing our time zones. Up until the 19th century, towns and villages synchronized their clocks to the local solar noon. This created thousands of local times that all varied and made scheduling transportation a major headache. Train schedules in different cities had to list dozens of arrival and departure times for each train to account for all the many time zones. On November 18, 1883, railroad companies in the United States and Canada began using a system very similar to the standardized time zones we still use today. In the UK, the railroad companies began using a standard London base time in 1840. After an engineer named Sanford Fleming missed a train in 1876, he set out to change the way time worked. He originally proposed a concept he called cosmic time, in which the world would run off an imaginary clock located at the planet's center, essentially a line from the center of the planet to the sun. He then suggested splitting the world into 24 time zones labeled with a letter of the alphabet, with each zone spanning 15 degrees of longitude. His original plan to create a standard cosmic time was rejected, but it did lay the groundwork for a similar standardization, so-called universal time. And nations present at the 1884 International Meridian Conference laid the groundwork for dividing the world into 24 time zones, with the prime meridian, also known as longitude 0 degrees, running through Greenwich, England. Even with the advent of standardized time, people still struggled to keep their clocks in sync. One London family used this to their advantage and made a living by selling people the time. An astronomer named John Belleville would set his pocket watch to the time at the Royal Observatory, Greenwich. He would then travel around the city and visit his network of subscribers, who paid to set their own clocks by Belleville's pocket watch. After Belleville died in 1856, his wife, and then later their daughter Ruth, carried on the tradition. Ruth continued to sell the time until World War II. By then she was in her 80s, and a couple of factors led to her timely retirement. Improved technology had made her role less important, and the war was making treks around London too dangerous. Time zones can still be a bit complicated. Big countries like Canada and the United States have multiple time zones, whereas China, another large country, has only one. China adopted the Beijing Standard Time to foster unity, but the effect can feel a bit uncanny. Two cities in the country can be at roughly the same latitude, but experience sunrise hours apart, according to their clocks. In some parts of China, for example, the sun doesn't rise until nearly 10 a.m. Speaking of confusing time changes, here are a few facts about daylight saving time. Though a lot of people believe the biannual time change was adopted to keep farmers happy, that's a myth. The first person to seriously advocate for daylight saving time was an entomologist who wanted more sunlit hours to look for insects after work in the summer. He proposed his idea to a scientific society in New Zealand in 1895. Daylight saving time wasn't officially implemented until 1916, when Germany became the first country to adopt it in an effort to conserve coal during World War I. The United States didn't follow suit until 1918. Daylight saving time ended on a national level after the war, but individual states and municipalities kept it going until World War II, when the entire nation went on what was effectively a year-round daylight saving time. After World War II, the entire nation was again picking and choosing daylight saving time. It's been reported that in Iowa, back in 1964, there were 23 different combinations of dates that communities turned on and off daylight saving time. In 1966, the government officially mandated a standardized daylight saving time for the entire United States, though individual states can opt out. Up until 2007, daylight saving time ended in October. It's been reported that the candy industry lobbied to wait until after Halloween to change the clocks back an hour. Daylight saving time does more than make people lose an hour of sleep. It can have some pretty concerning health effects. Studies have linked daylight saving time with an uptick in heart attacks, car crashes, and mining injuries. The extra hour of daylight is good for koalas, though. Researchers found that koala car collisions went down by up to 11% during daylight saving time. We can't talk about time without mentioning a few clock facts. People have been tracking time for thousands of years. In 2013, archaeologists found what's thought to be the world's oldest lunar calendar while excavating a field in Scotland. The calendar, which is made of a series of 12 pits that mimic the moon's phases, dates back to around 8000 BCE. Sundials read differently depending on the hemisphere you're in. In the northern hemisphere, the sun casts a shadow that moves from north to east to south to west. In the southern hemisphere, the shadow moves in the opposite direction. Our concept of clockwise is based on the way sundials in the northern hemisphere told time. In 1090, an innovative clock was built in China. A man named Su Song created a water-powered clock tower that measured time and tracked the movements of the planets and stars in the night sky. Su Song built a giant water wheel within the clock tower. Buckets attached to the wheel would fill with water and then tip once full, causing the wheel to rotate, demarcating time. The Maya had multiple calendars to measure time, but the most familiar to apocalyptic crackpots is the long count calendar. These calendars measured around 5,125 years, beginning around August 3114 BCE. The long count calendar cycle came to an end around December 21, 2012, sparking a craze of Armageddon conspiracy theories. You'll find the most accurate clock at the National Institute of Standards and Technology in Boulder, Colorado. The clock keeps time by measuring the vibration of a single aluminum ion and should remain accurate for 33 billion years. The clock sitting on your bedside table isn't quite as precise. If you've bought a new clock or watch recently, you may have noticed that the default setting was 10:10, give or take a few minutes. There are various theories behind this particular choice of time, but really it all comes down to aesthetics. Setting the time to around 10:10 allows the hands of an analog clock to be displayed in a neat, symmetrical way that doesn't obscure any logos in the center of the clock's face. Clocks were once set to 8:20 and occasionally still are, but the hand's downward angles can make it look like the timepieces are frowning. Traveling back in time is possible, theoretically at least. According to Einstein's theory, you could travel back in time by moving faster than the speed of light, as long as you could somehow have infinite mass. Since that probably won't work, you could create wormholes between 2 points in space-time. This would also be tough since humanity still hasn't invented the technology to actually build a wormhole. So, you could try bending space-time by plucking some cosmic strings. Two of these theoretical strings, which are thin streams of pure energy that are moving in opposite directions at very near the speed of light, could theoretically warp space-time enough to create a closed, time-like curve, also known as a time machine. Our next episode is all about the infamous body parts of historical figures. If you know of a strange, funny, or otherwise interesting story behind a historical body part, leave it in the comments for a chance to be featured in that episode. Thanks for watching.